So let's get into the main topic of today, which is survival analysis. That's the type of the analysis, or like a sort of like a frame, like a methodology. And behind that, like there are a bunch of different type of algorithms. But today, especially, we're going to use something called a survival curve or Kaplan-Meyer algorithm. I'm going to introduce that in this session. But so here's the agenda. First, I want to introduce survival analysis, or in more in the world, like especially like us, like living in a SaaS, software as a service or subscription business model, we call this type of analysis cohort analysis. So I'm going to introduce this topic one by one. So like start with survival analysis with survival curve, then like apply that to the something called cohort analysis. And then like we also like I want to talk about like how to understand that the kind of information these algorithms can bring, or this type of analytics can bring us. So there's certain like terminology. So like I want to give you a quick overview of those as well. Okay, so the survival analysis is all about it's when. It's not about if. So it's not about if. The reason I say this is that, so let's say like, for example, like if you have the customers, right? And your customers, you want the customers to convert. Sorry, like let's say like you have a freemium business model or something like that, and your users are trying your product or service, and then like you want them to convert, becoming the paid customers. Or in our kind of business, we also care about the customer canceling the service, right? So like maybe the customer sign up and become the customers, but then 2 months later, like it quits, and then that means we lose the business opportunity. So that is called a cancellation, but also in this world, we call it churn. So then the question is like, can we predict if this customer is going to churn or not, or this customer is going to convert or not? So those are like if question. But when you think about it, like when canceling the service, eventually everybody will cancel, right? So like it's maybe like 3 months later, or maybe 6 months later, or maybe like 10 years later, at a certain point of time, like everybody will cancel, most likely. So we're not interested in here, like we're not interested in if the customer cancel or not, because like everybody will cancel, but we are interested in when this customer is going to cancel, or precisely how long the customer will stay being a customer before the cancellation happens. So that's what I mean by like, it's not about the if, it's about when. It's the time to that event to happen. So that event I'm talking about here is because let's say like in this kind of subscription business, we tend to talk about a customer churn, which is the last bullet point, but can be other events. So if you are at the hospital, you're interested in if the your patients die or not. So let's say like you're testing if this medicine works or not. And then like if you know like patients eventually will die, we all die regardless if we are sick or not. So, but you're interested in like how long the patients will survive, longer or shorter, by providing certain type of medicine. Or like let's say like you're a manufacturing business, you release the cars or stereo or whatever, but those types of things eventually break. So it's not about if break or not, but it's about like when breaks, and how long that thing can go on before it breaks. And then like in the HR business, like you have the employee, and the employee again eventually quit or leave the company, but it's about like, does it take like 3 years or 20 years before those employees leave the company? So again, not interested in if the event will happen or not. We are interested in how long it takes for that event to happen. Okay, so and then, so basically, eventually though, like what we want to understand is what are the variables and how those variables impact or like are associated with the time to event. So let's say, for example, the customers from US, customers from Brazil, which customers have the different sort of like a pattern when it comes to the time to an event. So maybe the customers or like the users in America tend to stay longer, and the users in Brazil tend to quit quicker. And so we want to understand those things. Can be the country, can be the operating systems they use, can be like a gender, can be the age, whatever the variables, right? And then like once we understand it, then we can do something to improve the service in a certain area or so on. Okay, so to do the basic thing is something called survival curve. Survival curve is about like x-axis in the time horizon. So how long that time pass. So for example, it can be like a month, it can be week, year, whatever, but it's just a time, right? So as the time goes, and what is the survival rate? How the survival rate decrease. So if we agree that everybody leave the company or service or whatever, then eventually like this survival rate or like a retention rate goes down to 0, right? But the curve starts from like 100%. That means nobody quit, and then go all the way down to the 0. And then like we are interested in like how this curve is sort of a slow or moderate, or is steep drop down. That means that people are like dropping down like super quickly. So we want to use this visualization or this chart to understand how our survival or retention rate are by using the time horizon. Okay, so let's use some example. So like let's assume like this like exploratory or like whatever the SaaS business or subscription business, and then like we have the customers, and we're interested in like how the customers are leaving or like how long the customers stay before they leave, right? So let's imagine like we have 4 users or customers, okay, and then like we have like a January, February, March, April, like we have 4 months that we are observing, right? And then all of them, let's assume, join in January. And then second person, Tien, canceled in March. And then the last person, Victor, canceled in February. But the other, the Jessica and Nancy, they're still like at the April time, like they're still using, okay? And then we are not interested in the particular months, like let's say this is a 2019 April or something like that. We're interested in how long does it take, has it passed, right? So let's say like so we're gonna rename this time axis to be like a first month, second month, third month, 4 months, fourth month. We don't care about January or February, that kind of stuff. Okay, then we can start calculate the survival rate for each months, right? So like a first month, nobody quit. So it's the survival rate or the retention rate is 100%, like just 1, right? And then the next month, the second month, like out of 4, the 1 person cancel. So that means for this month, when we focus on this second month, the survival rate or retention rate is 75%. So like 0.75, 75%. And in the next month, the third month, we had 3 people, and then out of 3, like 1 person left the service. So now it's a 66%. And then last month, like 4th month, like nobody left, so it's 100%. So the survival rate of that particular month is 100%. Okay, and then that we are focusing on so far, like we're focusing on each month, like what is the chance of like leaving in the particular month period. But then like what we care is like a survival rate through the period. What I mean by is like what is the probability or what is the chance that like this person is going to survive till second month, or till third month, or till 4th month. So to calculate, it's pretty simple. You just multiply by the any given particular month's survival rate, and then multiply that by the previous survival rate. So 1 multiplied 0.75 becomes 0.75. So now we can say like if the probability or the probability, the rate that any given user to survive till second month is a 75%. And we can do the same thing for the third month. Like we just multiply the previous survival rate to the current survival rate, and then we get that 0.5, right? And then we do the same thing for the last person. So now from here, what we can say is like for our customers, for them to survive through 4th month is 50% of the chance. So that's how we can calculate. And then like basically like we can just use these numbers and then draw the line from first month to the fourth month, and from 100% to the 50%, that's the survival curve you get. Now, though, in reality, like most of the cases, like no service have all the customers sign up on the exact same month and period, no new customer or something like that. Typically what happens is that every month there are new customers, right? So like we have, let's say like January, we have 2 customers sign up, and in February, there are 3 customers sign up, and so on. Then again, we are not interested in like this is like a March, this is August. We are interested in how long does it take. So therefore, like is this the first month for this particular customer? Is the second month for this particular customer, or something like that? So we're going to align them all the way to the left. So like first month, second month, third month, fourth month. Then we can calculate the survival rate, and then like we did before. But here's a problem. The third person and then the fourth person, they sign up relatively recently, right? So therefore, we don't know these people will survive for example, the third person to survive in the fourth month, or the last person to survive in the second month. We don't know yet, because those are the period for the future period for these users or these customers. So the second from the last, though, we know because this person canceled in the second month. So we don't care if the third month or fourth month for this particular person, because this person already canceled. So the problem is the people who are still using as of today, but still just joined last month or joined 2 months ago, still kind of relatively short compared to other users. And those are like, we don't know. And then in this survival analysis, we label them as something called censored, that basically like we don't know them. So we basically just label in a kind of a special thing. And then when we calculate the survival rate, we don't include them. So for example, the second month here, we have 5 people, but the last person, we don't know if this person survived or not. So we exclude it. Then we can calculate the survival rate as 3 people who are still surviving divided by the 4, right? 3 green plus 1 red. And then like we can calculate that 75. We do the same thing for the third month and the fourth month. And then same thing, that we are not interested in survival rate for each month. We are interested in the survival rate through the particular month. So like the second month 0.75, and third month is like 0.66 multiplied 0.75 becomes 0.5, and so on. Okay, so that is basically how we want to calculate the survival rate or retention rate in a more reasonable manner, or more like a right way, or better way, I should say. But in order to do this type of calculation, it's kind of like a cumbersome. You can eventually do it by using Excel or using Exploratory, by doing the calculation by hands, but it's just cumbersome. And that's where the Kaplan-Meyer algorithm come in. And then this algorithm can take care of not only those like a survival rates through the any given time, but also it can take care of that censored data. It can label who shouldn't be included in the particular calculation. Okay, so the detail, I just put some like notes for this Kaplan-Meyer estimator algorithm, but basically like what I have already explained. There's not much new information here, but so if you're interested in, you can take a look at this slide later. But it's this basically think of it like this algorithm can help us to get those numbers. Okay. So enough about the talking. So like I want to actually start like showing the demo, and then I'm gonna I have already uploaded this data, so you can after this you can download and then import in Exploratory, and you can do it if you're interested in. But this is a user access data. This is very typical. So like each user has the start date, right? Like typically the start date can be the time like they started using the service, or the time that they converted as a customer, let's say like putting in a credit card information, whatever. And then the end date, usually the date they cancel, right? Or if the user is still using as of today, then this end date might be today, or might be like just NA, still because still using. Either way. And then canceled or not, right? So if this user cancel or not, and then like other attributes, where the customer's coming from, what operating system using. And then here's one thing before you're using survival analysis algorithm. So today we're going to use a Kaplan-Meyer called survival. We call it survival curve, but there are other algorithms in this family, and then such as Cox regression. I might touch that towards the end of the time on this session if we have time. But to use those, you have to have the data in a certain format. And it's not that hard, but it's just there's some kind of rule. So each row represents one observation, in this case, a customer, or it could be employee, it could be patient. And each row has at least two types of information, and start date and end date, so that like, we can calculate the lifetime. So how long this customer is using this service for. And then the second type of information is the event status, which is that canceled or not, or this employee quit or not, if this patient died or not. So that event status, typically the true and false. So in this data, each row represents one customer. So that's good. If not, then you want to aggregate, you want to summarize the data to get this particular point. And then the start date and end date. So this is these are the two columns that we need, especially in the exploratory, or like basically to calculate the lifetime. And then event status, like true or false, if this customer canceled or not. Okay, and that's it. And then let's get started. So here, exploratory, like I have already imported this data. So this data, link to this data where you can download is going to be listed on our online seminar page along with the video on the slide. But so we have this data, and then we have a 2,171 rows. That means 2,171 customers. Then we have here the cancel. That's the event. So true is about half, right? Like 44% of the customers already left, and then 55% still using. And then the OS, operating system, Windows and Mac, and the country, United States is the highest, and Japan, United Kingdom, and so on. And there are about like 87 countries. There are a lot of countries here. Okay, and then to do, like we can go to the analytics. Before though, typically when we do this in our training, like more like online, sometimes we do the booster training or bootcamp training kind of stuff. Typically, we don't start from here. We usually start from like access log, like, which means like when this customer used the service or not, that more detailed data. So that means one person's or one customer's data can be, can have like a 10 records or like a 50 records, as many days they use. So, but then we do the data wrangling to aggregate the data to get this point. So if you happen to have that type of detailed data and you are not sure, you can actually do the summarize and group by and summarize. You're not sure how to do, feel free to contact me later, and I'll show you, I'll guide you to the document that talks about that. But anyway, so let's assume that we have this nice data, which rarely happen, but let's assume we get that data. And then on the analytics view, like you can select survival analysis. We want to select survival curve here. Okay. And once you select the survival curve, then like we want to assign what is the start date column, what is the end date column. So these two information eventually behind the scene will be used to calculate the lifetime of each customer. And then the period, so this is like that when eventually what we're going to do here is to draw the survival curve, right? That line chart. So what is that, like how detailed you want to see? What is the scale? So here, let's use months so that like we can see like months, the survival rate or retention rate, monthly retention rate. And then the event status is that canceled column, true, false column. And then let's click run button. And then this is the first survival curve chart we get. And then, so the y-axis is the survival rate, or in this subscription business lingo, it's a retention rate, right? Like how much of the customers remaining in terms of ratio. So for example, and then the x-axis is a time horizon. Right now, we selected period by month. That means this is the first month, second month, third month. So we can read it as like a first month. By the first time, the chance or the probability or the ratio of our customers still using this service are 66%. So like 66% of people like still use in the first month. And in the second month, it's going to go down to 62, and the third month is 60%. So that this is kind of typical. Like the first month, like there's a huge drop because some people like kind of like wanted to try out, and then the first month they don't get it, so like they quit or whatever the reason they quit. But the people who tend to keep using the second month, third month, usually they already understand the value or their needs and the product or solution are matching rightly. So therefore, they tend to keep using it. So the curve typically goes slow down. Otherwise, there's some problem there. But anyway, so we get the first curve. And then here, like we have the width range. So like you can show it with a confidence interval. This like 95% confidence interval. This type of data in the statistical world varies. So there's a variance. And as the users, I think the number of the user goes down as the time passes. So let's say like the people using still like after like 8 months, is much less than the people use in the first month, right? So like when you have like less people, then like start being less confident, and so that's what you see. Like it tend to be this confidence range start going become bigger. And then here's a survival table. This table is basically, these are the numbers becomes the line chart. So you're basically seeing the same thing here. And then the data, like you have like a time, risk, event, sensor, all that stuff. This is kind of like intimidating language here, but what it is, it's not actually that complicated. So the time is like basically we are seeing the time horizon at the x-axis, same information. And then the estimate, that's the percentage of the survival rate, right? So 99%, 66%, and so on. So these time and estimate are the ones used in the line chart. Now, in risk is the people who might have that kind of risk of the event. So typically, so basically the time period 0, we had 2,171. This is the starting point. And the first month, we had only 2,145. Right? So this is like the people start with in this particular month. And then the event are the people who that event happened to these people. So the first month, 18 people, the period 0, it's almost like the same day. Like 18 people not died, quit or left. Maybe this data might have like only the people who just access only once, and then maybe even though put the credit card, but they never come back or something like that. And then first period is 710 people left, so it's pretty high number. And then but what we are using here is like a risk and event. These are the base numbers to calculate the estimate. And censor are the people who we don't know. So let's say like this first month we have 183 people, we don't know what they're going to do. They're going to leave or not, because these people just started using it. For them, the first month actually haven't come yet. So that's why like we have this number. These numbers are excluded from the original number, and therefore outside of risk number. Okay. So that's the, I think I have a slide that explain here with the chart as well. So this might be easier to understand to get the understanding of this. Okay, so now let's get, so this much, like now we get the survival curve, but it's sort of like we understand like, okay, 60% of people leave and so on, so that's great. But typically, like we still don't know like what to take of this. Is this a good survival curve or a bad survival curve? So let's say like if this is a survival curve for our company, like Exploratory, then of course like we want to compare against our competitors or other businesses. But typically we don't have those data, right? So like how are we going to compare, able to compare? But what we usually do is something called cohort analysis. And that's the second topic I want to start getting into. So cohort analysis is nothing but basically it's this whole lingo. Survival analysis was developed in a medical field. So therefore, some of the word is, that's why we call it survival, because the patient survived the next month or that kind of stuff. And also the cohort is also being used in that industry, but it's, most of us for us, it's basically a group or segmentation, right? Just a different groups. And then somehow this type of analysis is called cohort. So let's say that the country can be the cohort. Let's say operating system can be the cohort. And then typically what happens in our industry is we look at like when the user joined. Let's say like joined January or February, March, depends on when they join and when they start using the service. And then like we make those information as a cohort, the group as a cohort. So I'm going to actually talk about, start showing how you can actually do that from here. So then typically you get, like, let's say we have two groups, then like we compare, now we can compare which one is better or not, right? So like kind of relatively, we compare them. And then like we can come up with some kind of hypothesis of like, hey, this is working or not working kind of stuff. Imagine like you have like two groups and then, maybe like you're testing a different pricing and then stuff, and then like you see like two different survival rate, then like you can say like which one is better or not, right? So that's something that how you're gonna do it. It's actually pretty simple. All you need to do is use this color by. And here, let's use this operating system, right? And then like the operating system is basically like each user has, let's say this user uses Mac computer or Windows and so on. Let's assume like we have only two operating systems here. And then like you assign that to the color and then you click on the run button. Then you get two lines. So like here, immediately what we can see from here is like the users who are using Mac OS in terms of survival rate is better. And then the Windows users, so like for example, just to see the first month, Mac users, 70% of users still remain or still using it. That means 30% of users quit. Windows is 63% remain, and then that means 37% quit, right? So we can see like Mac users better. So like something, I don't know, like maybe like Windows version of this service is not great, or just the nature of the Windows users, or like, we don't know, but like there's some difference there. And then like when the time goes through though, towards the end, like after like 7 months, it's pretty much the same. And then it's actually the Windows better and so on. But here now, like we are comparing two, and then like what we are trying to see is, say here is basically, is there any difference? Like if the operating system, like Mac or Windows, can make the difference in terms of this like a survival curve? And that's where like you want to actually go to the summary view. This summary view, when you click on it, there's nothing shows up when you don't have any color by. There's nothing to compare. But when you have something in the color by, then you're gonna see this thing, something called log rank test. So this is a statistical test. And then you can use this information to see like if that difference you're seeing here is something quote unquote statistically significant. Okay, so basically the important information here is something called p-value. And this is a very statistical, the word of statistics thing. And then typically, I mean, to understand this p-value can be tricky. Then usually like I spend like 1 hour in a class to go through this, and even then like it's still confusing. So but I'm going to try my best to explain quickly here. So what the p-value is used in a statistical test, right? And the p represents probability. So what probability we're talking about here is a probability of getting a given value, or in this case, the difference between the two curves, right? So like the Mac OS survival rate curve and then the Windows OS survival curve. And if we assume that there's no difference between the two, like Mac OS and Windows OS, if they don't make any difference, whatever the OS you use is pretty much the same. Like that's the sort of like hypothesis that we assume. Then what is the probability we are getting this kind of difference that we are seeing right now? Okay. So, when you measure things, even a conversion rate, right? Like let's say like every day, the conversion rate is different. How many customers convert today or no kind of stuff. Or even the cancellation rate or churn rate. Like every day you get different numbers. So just happen to be like today, like Windows users cancellation rate is 30%. And doesn't mean it's always 30%, right? So again, then maybe tomorrow it can be 60%. The day after tomorrow can be 25%. So the number always moves. And those movement can be just by the chance, by just random chance. There's nothing, like it really causing that behind the scene, or like nothing we can do about it. So the question here is, whatever the difference we are seeing right now, it can happen by chance, or actually that is happening more consistently. There's some kind of pattern between the operating the Mac and the Windows operating systems. And therefore, like we should pay more attention to it. Or the difference today is different, but tomorrow when we test it again, like in opposite way, maybe like Windows better. So that is really the p-value about. So if things can be different by chance, and what is the probability of getting that kind of chance? So here, what we get is here, p-value is 0.28, so 28%. So if Windows and a Mac, there's not much difference. Like users using Mac or Windows doesn't make any much difference in terms of survival rate. But then still, we can get this kind of difference. This type of the two lines difference is 30% of the chance. So 30% of the time, like you get this kind of difference. So now it's up to us to how to interpret this information. Is that like, oh yeah, it's like a happen all the time, or it's a very rare event, therefore there's something going on because of the operating system? And then, so it's really depends on the business practice, or depends on the pattern like you've been seeing with your business. This number can be like a 5%. In the classroom, people tend to use this convenient number, like a 5%. Then, like if you see this percentage higher than the 5%, that means, oh yeah, that can happen all the time. Therefore, whatever the difference you're seeing is just by chance. But if you see these p-values as like, let's say 0.1%, that means, hey, this kind of event, this kind of things you're seeing right now is rarely happen, like 0.1% of the chance, right? So therefore, that difference should be coming from this like difference of, like in this case, operating system. Okay, so 30% is kind of a tricky. Because in some field, for example, psychology field, like 30% is actually good. It's actually good. So like less than 30%, you can say like it's significantly different. But in like world of manufacturing, it's very more precision world. Then 30% is like absolutely like it's just a chance. Like right, they require p-value to be lower than like 0.0001% or something like that. So it really depends. So now, like all the sudden, it makes us kind of uncomfortable. Like, so how to treat this number? So in that case, intuitively speaking, so go to the with range. Now this one gives you with the confidence interval, right? So now, like when you look at here, like Mac and Windows, the first month, second month, third month, fourth month, around here, even with the confidence range, that means like the value can move. This much with a 95% interval, confidence interval, but it's not really duplicate, sort of like on top of each other. So that means even that some numbers moves, but then Windows and Mac are different, right? But when you go to like a period 5, 6, 7, and these lines start on top of each other, that means, hey, maybe, like when you just happen, but maybe like when we get more users, or when we, test again, the order can be different. Like Windows better, or the Mac is better, or like vice versa. So this is what's happening. Then we can say, even though like summary is like 30%, but probably like the period 1, 2, 3, there are difference. But because of period 4, 5, 6, 7, 8, 9 are so close, That's why this p-value number is becoming bigger. So if you're not used to like p-value thing, then like try see this with range and try to understand this intuitively first. And then like once you start kind of like changing this color by or cohort in these different type of groups, then you start getting more like you start getting more used to it. Then you will know like what the p-value really is and how useful that can be. Okay, so now this is like an operating system. And then like what we can do is like we can also compare with other things like let's say like a country. So like, hey, I want to see by the country, and then or like other things as well. So here one thing is a country. Like if you click on run button by assigning country, you remember like we have 86 countries here, right? When you go to the summary view, like we have 87 countries. Then what happened is a default. That's too much, right? You're going to see like too many lines. So therefore, this color by automatically takes the first 20 groups, in this case, 20 countries, based on like how many records are, which means basically from here, the top 20, and then make the rest as other group. So that's what's happening. So when you click on this green button, it says keep only most frequent. If you uncheck it, then you're going to see like 87 countries here, but that would be kind of too much. And then sometimes like it's better to just kind of start with small. Like let's say like I want to keep only 3 countries, and everything else I want to put them into the other. And then like now I'm seeing like Japan, United Kingdom, United States, and others, right? So these 3, where the 3 coming from, the United States, Japan, United Kingdom, these 3, and everything else becomes other right now. And then basically what we're seeing here, the United Kingdom is like the retention rate or survival rate is much better than the other groups, and other groups almost like kind of the same. And when you go to the summary view and the p-value actually went down 0.15, in this case, it's kind of hard because we are comparing 4 different cohorts together. So like, I don't know like what difference we are testing here. So when you test, typically it's better to test just 1 or 2 things and then A and B. But nonetheless, you can still see there are some differences. And then the difference probably coming from this difference. And then we go to the with range, and the United Kingdom is at top. But notice though, the confidence interval of United Kingdom is much bigger than the confidence interval of United States. And that's because we have more data for the United States than the United Kingdom. So therefore, there's that difference. Okay, so now, so you can do these types of things, but also other thing would be interesting is when the user join, and that's a very typical thing we do in the SaaS business. And that, in order to do, you can actually assign. So basically, here's a start date, right? So when the user join, and then based on the information we want to segment or we want to create different groups, then we want to assign this start date as a join date, right? And to the color by. But the problem is you can't select it here in Exploratory. And that's because it's already used in the start time. And what we're going to do, well, that's pretty simple. You go to the table or summary view and just copy this start date as a join date column. And then like, you can use that. So that's it. So then how you copy it? Well, from column header menu, and then select this mutate, create calculation. There's nothing you need to do here. Just keep it start date. This is a column name. And that means once we create the new column, this column is going to basically get the value of the start date. But let's just change this name is as a join date or something. And then when you click on it, a run button, then we get a new column, which is basically a copy, exact the same value of the start date. And then once we get this and then go to the analytics view, and then assign that to color by, but we don't see that column. And why? Because it's just like a chart, like analytics do, each analytics can be pinned to the particular step. So in this case, it's pinned to the first step, before creating the join date column. So therefore, like whatever that you did here or the later steps are not going to be available here. So we can actually move this pin button to drag and drop or click and re-click to change move the step. So now whatever the data that we can throw into the survival algorithm can be coming from the second step instead of the first step. And this each step, think of it as a kind of like Excel's sheet inside a worksheet, except these are connected. It's more like a data wrangling process, so the pipeline. So second one's based on built on top of the first step. But anyway, so that's a wrangling side of things. And then what we care is we want to assign the join date. Now that we see the join date, right? And then we want to do is here the default year. That's the scale. But then we have only I think this data is the 2016 data. Then if we run it, we're going to have only one line because there's only 2016. What we want to do is we want to create the groups based on which months they join. So like forward 2 months, or you can select the months here. The difference is you select months here, then it chop off the year information. If you want to keep the year information like forward 2 months, that means if you have like a 2019 July 4th, then that data becomes 2019 July 1st, or July 4th, or July 5th, July 15th, whatever, all becomes July 1st. It's kind of like a rounding numbers, and very similar thing, but it's flooring. It's always like bring it down to the first. So like now forward 2 months, when you select that, and then click run button, then you get like 2016 681. That's kind of weird, and that's because remember when we assigned a country, it actually did some kind of like a most frequent thing. So click on the green button, and this time we don't need that. So like uncheck keep only most frequent thing, then apply button. Now we see all the cohorts here. So start from 2016 May 1st, and then June, July, and then all that way up to 2017 February, right? And then like basically what we're seeing here is like the retention curve or survival curve for each cohort. In this case, the joined months. Okay, so now like we can see, for example, this blue line, 2016 May, is basically the best after this like a purple line, but other than that, it's pretty good, right? It used to be nice survival curve. It's that, remember, like it's curve, the more moderate or more slowly going down is better here. So used to be, I think the customers stay like 74% in the first month, but when you, as the time passes, like I think the start thing going down. So for example, 2016 July is here, right? And then compared to 2 months before, it dropped down. So like there's something going on. And then, but this can happen, you know, the more user you get and the more user quit and stuff. So, and also the more user, this is a ratio, so that shouldn't make much difference. But sometimes the more user you start getting, some people like come from like, you know, different places, and they're, you know, it's not necessarily their demand and the product solution matching, but they just sign up anyway. So like that can happen. But nonetheless, seems like as the time goes through and then the survival rate start kind of coming down, but then like around here is like 2016, the bottom part is this one. It's like August or September. And but after that, I think here is like a November, December, things start going better. So it seems like, you know, like they have done something to, you know, make the service better. They have done something to improve the product. They have done something in the marketing or customer onboarding. I don't know, but things are getting better. But in this way, like basically, like you're seeing, it's that each segment or each cohort, you're basically tracking like how they survive or how they retain. But also like you're looking at the time horizon over based on when they join. So like recent customers are still high ratio that they're using it. And then, and that's actually the better sign. But if you see the survival rate going down, that means something wrong. So like you gotta start, you gotta take action immediately, right? So this chart being used very, very often. Or you might sometimes see like this kind of chart. This is a more table view or heat map view, but basically the same thing. But very often in the startup business or like a SaaS business. And then this can be used for like employee data. This can be used for manufacturing data, medical, and so on as well. Last result here, like there's a repeat buy. So I want to see, you remember like we had an operating system country information? So like I want to see like the Mac users, I want to see like how the survival rate is moving, performing. So let's say like if I assign operating system and I click run button. Then here, so that this 2016, all this time period of the cohort, the reason this one was better is probably because of Windows users, it seems like. And then also another thing I noticed here is like 2016 July, Windows users pretty bad, where Mac users compared to Windows, not as bad. So like very typical, like you see different pattern in a different group, in this case, Mac and Windows, or like think of it like when you change a country and then when you run it. And I think again, the country has 87. So like you're gonna see either like a crazy number of the cohort or hope not. Yeah, I think it tried to do like 87 countries, which I shouldn't have done. But you're gonna see those things. Ooh, what is going to do? Oh, here you go. There's a 20 groups. Okay, so that's a lot. And I don't need a 20 group. So like I'm going to change that to like a first 3 or something. Then let's run again. Now like I should see like only 3 countries plus other. And then like I can change this setting to go to the chart. It's changing this, how many charts in the one row. So like, for example, like I'm going to change that to 2. This is going to make like a 2 charts in a one row. So like now 2 by 2, and I'm looking at here, and I can see different patterns in each country. And then ideally, like all the countries should be, like all the survival curve getting better in every single region, but that's probably not the case. So like when you start seeing something like some weird thing going on in a particular country, that's where you should think, hey, maybe like we should take some action. This is a country, can be operating system, can be the type of the business license model. Let's say like our Exploratory, we have like a business edition and a personal edition. So maybe there might be some different. The way customers come, maybe the channel, like the Twitter or the Facebook or Google search, there might be something different. And those are the things we want to understand. And then you go to the summary view, and then you can see this p-value for each country in this case. So Japan is 0.37. So like a 37% of the chance that this kind of difference can happen. So maybe in Japan, there's not much difference among the cohort with Japan here. These differences might be by chance. But here, the other group and United States and the United Kingdom, there's significant difference. So like that's what we are seeing here. Okay, so that's the brief overview of the survival curve and also the cohort analysis. As a bonus though, typically what happened after this is that, so what makes good, what makes bad, right? So like what makes the survival rate better? So what makes the survival curve worse? What are the things that make this curve going down? What are the things going up, right? So what we are doing here is basically, let's say going back to like operating system. And then here, what we learn is like Mac users tend to have a better survival rate than the Windows users. And then we wanna, but this is operating system. But typically, let's say like your service is, like a cloud service, and what, pages like users are visiting. Let's say like going to this particular page, maybe design page or sports page or like a news page or something like that. Then like what are the things that like actually making the users survival rate better or retention rate better or not? So those are the insights that like, eventually like, we're looking for. Then we can take actions, right? So to do, I want to show you the last thing here. Very similar data. This particular data has user start end time, and then like cancel or not that information. And plus, imagine this service is like a social network, like a Facebook kind of things. And then so you have the attributes, and then the value is 0 or 1. So for example, this is like a receive friend request. So these users receive this friend request in the first week or something. Well, this user click on the like button in the first week or not. And if it's 1, that means this given user did. If it's 0, this given user didn't do it, right? So we have this type of information. And typically it shouldn't be like only 6. You have like a 20 or 30 or 100 or whatever. But let's assume we have this data for each user. Then what you can do here is, for example, like if you do like a survival curve, right? So we're going to do the exact same thing we did before. This is nothing special here. We've been doing this. And then let's say like if this user depends if users add the birthday into the system or not, and then does that make any difference? Now when you look at it here, it's like you have two charts, and then this seems like there's not much difference. The p-value is 0.62, and with range is like overriding each other. I mean, on top of each other. So probably this event wouldn't make any difference in terms of the retention rate or survival rate. But how about the other? And if you have only like 5 or 6, I mean, that's fine. But when you start having like a 20, 30, it's just too much of the work. So that's where like there's something called Cox regression. And that's basically similar to linear or logistic regression. It's a statistical algorithm. And then, like, but you can use this to see which variables are more associated with this event or like the survival curve, right? So predictor here, like I'm going to select all these 6 attributes or the variables, and eventually, like I want to see like which variables are affecting to the outcome. In this case, a survival curve. So here, receive friend request timeline post. These are the red color. That means like a negative impact to the event. So negative impact though is like canceled true, and the negative is like a false here. So that means it's not going to cancel. So like not cancel. So when you see the red, is actually in this particular scenario is actually good. And then when you see the gray color, that means it's higher p-value. Therefore, these are not significant. So we want to pay attention to either blue or red. And then like, what that means, like receive friend request and timeline post like this red, how should I interpret this? Well, you go back to the survival curve and then assign that to, let's say, receive friend request to the color by, and then just click run. And then sure enough, receive request, when you have like a 1, that means this user did, or like the type that this group of users actually use this particular feature, the orange line, right? The 1 is orange line. And these users' survival rate is better, survival curve is better than the users who didn't use this functionality or the feature. And that's what basically you're seeing here. So like you see, you use Cox regression to identify which are the variables that we should explore more, and then go back to the survival curve. This is, think of it as more like just a visualization, just a line chart, except it does a little bit of advanced calculation behind the scene, but then you can find this difference. And then, so this way, like I think it's kind of like easier to find like which variable to focus, and then go back in here, and then so this is basically the same thing like I did last week with the random forest using the algorithm or the modeling stuff. This Cox regression is a predictive model, or it's building a model behind the scene, and it's great. But at the same time, you don't know like intuitively what that model is really saying. So you always better to just use a visualization to understand it more intuitively, not only for you, but also the people you're going to be communicating with appreciate this type of visualization as well. Okay, so that's it for today. And then like, with that, like, I want to open up the Q&A session. And then if you have any questions, please feel free to jump in. Like you're all mute, so you need to unmute yourself, or the chat window is open. So